1.4 Sustainability, Part 4. Now, factors such as biodiversity, pollution, population, or climate may be used to quantitatively, so it's measuring, as environmental indicators of sustainability. These factors may be applied to on a range of scales from local to global. The Millennium Ecosystem Assessment, or the MA, gave a scientific appraisal of the condition and trends in the world's ecosystems and the services they provide using environmental indicators, as well as the scientific basis for action to conserve and use them sustainably. Now, that is a lot of information. We've got biodiversity, pollution, population, climate, being used quantitatively environmental indicators. We've introduced the idea of the Millennium Ecosystem Assessment, the MA. So it's an information overload, so let's break it down. So starting the first step, factors such as biodiversity, pollution, populations, or climate may be used quantitatively as environmental indicators of sustainability. So biodiversity, keeping in mind that greater diversity means greater ecosystem stability, as well as being able to better withstand changes, thus more sustainable. So the higher the diversity, the more sustainable an ecosystem is. How can we measure that? We could use a tool such as the Simpson's Diversity Index to quantify diversity. Quantifying this diversity helps make decisions regarding conservation actions as outlined in topic 3. So the Simpson's Diversity Index is in topic 2, and what you're starting to see is the different units all coming together here. Next, we're going to take a look at the pollution, and in terms of pollution, less pollution means a lower impact on organisms, thus more sustainable. We can look at atmospheric pollution in terms of particles in the atmosphere, or maybe tropospheric ozone being produced. But again, it's much easier to look at the aquatic pollution, so levels of TDS, total dissolved solids, and also an indirect measure of pollution, biochemical oxygen demand, and dissolved oxygen. So pollution may change ecosystems' abiotic factors beyond organisms' optimal range for survival. And for that, you can look at topic 1.5, humans and pollution, as well as the ESS topic 4.4, water pollution, for a more complete picture of this process. And you can now see how this pollution links back to biodiversity. We now take a look, I'll move myself over here. Populations. An increasing human population means more environmental pressure as we use those services, use those goods, and that becomes less sustainable. There's also increasing plant and animal populations. Generally, that means for more stable ecosystems and more sustainable. Now remember, human population is not always directly related to less sustainability. It's in fact our consumption levels. So more people use more resources, thereby increasing a population's ecological footprint. But remember, behavior can be huge as well for environmental impacts of human population sizes. More plants and animals provide more energy, more nutrient pathways through ecosystems, and that's topic 2.3. Finally, we're going to look at climate, and in that case, we're looking at stable levels of GHGs, that's global greenhouse gases, and stable temperatures. We have to have the greenhouse effect, so greenhouse gases, and means stable temperatures, but too many means we'll have a new steady state that's a lot warmer. And what we can see here is that, remember, the environment chooses which organisms are best adapted for survival, that's the fitness, by means of natural selection. If we change, a changing environment increases selection pressure on organisms, making them less likely to survive. Looking here, we can see a core set of global environmental indicators. So there's a range of scales. Here we're looking at things like energy, atmosphere, biodiversity, ozone depletion, forest. You can see that the red, the orange colors are the most worsening indicators that things are much better, and those blues. So you can start to see in the atmosphere there's some worrying trends. In the ocean, there's some things of concern. In terms of energy, not too bad. Ozone depletion, things have actually improved. In terms of biodiversity, there's not data in some areas, so that's important to know too. Taking a look now at the Millennium Ecosystem Assessment, MI, it gave a scientific appraisal of the condition and trends in the world's ecosystems and the services they provide using environmental indicators, as well as the scientific basis for action to conserve and use them sustainably. So data-driven, data in, helps us make our decisions, which are also data-driven. Looking forward, we can see that the aim of the Millennium Ecosystem Assessment, or the MA, assesses the consequences of ecosystem change for human well-being. So what are the overall findings? We can see that more diversity loss in the past 50 years than any other time in human history, and it's linked to human activity. There are gains in human wealth and health, and those have come at a cost to ecological goods and services. There's a global natural capital is being harvested unsustainably. An example of that would be depleting fish stocks. Ecosystem degradation will lead to long-term harm to human populations who rely on the services and even just the natural beauty. Finally, sustainable solutions are possible, achievable, and in many cases, economically viable, but require international coordination and collaboration to implement change. And a great example of that is the depletion of the ozone layer.